In this video, we're going to take a look at solving systems of equations by substitution. This is one of three methods that we will use to solve systems in our unit. So far, we've seen solving a system by graphing, where we have two equations of lines, we graph them on a grid, we see where they intersect. It's a good strategy to have. It can be very useful. But sometimes it's not as convenient if the lines don't intersect at a convenient place, such as decimal or fraction values. Sometimes those two lines are going to actually end up crossing way off the grid where we can't see them, and we have to hunt around for a while to go find where they would actually meet because we know that they would. That can be a time-consuming process. So for instances like that, it's nice to have an alternative strategy, such as substitution, where we can use algebraic process to figure out where that solution is without guessing and checking around in the xy coordinate plane. So the word substitute itself means to replace or interchange, and so that's the idea we're going to use here. And you'll see that we are given an equation, 4x plus 2y equals 20. And what we're going to end up doing is solving for x. And that's part of what we'll do. But we're just going to start with kind of learning what substitution is again, reminding ourselves. We have three scenarios that we're going to use. And you're going to notice in each of these scenarios that the equations are already solved for a variable, in this case, the variable y. So in example A, we have y equals 2. Example B, y equals 3x. And example C, y equals 4 minus x. This is the convenient setup for substitution because in each of these scenarios, essentially what we're being told is what the variable y can be replaced with, what we can interchange. So for example A, we are given a rule that y is equal to 2. So anywhere that we encounter the variable y, we could replace it with that value of 2. And so that's what we're going to do with our equation 4x plus 2y equals 20. We'll start with that, and then for the variable y, we'll end up replacing it with 2. So let's start with our equation, 4x plus 2y equals 20. But instead of leaving it like that, let's replace this variable y with what it's equal to. So we know that in this information here, y can be replaced with the value of 2. So we're going to replace this variable with a value of 2. And so now the equation reads 4x plus 2 times 2 equals 20. And a good strategy to use here is anytime you substitute, use parentheses because it's going to remind you to multiply or distribute if there's a number before those parentheses. And that's exactly what we have going on here. And so now that we've substituted, you notice we have an equation with just one variable, meaning if we can solve this equation, we'll know the value of x. So we'll go through our steps here to solve for x, and we'll get 4x plus 4 equals 20 because 2 times 2 gives us this 4. And solving, we know we need to subtract 4 on both sides, which will give us 4x equals 16. And when we divide by 4, we'll end up getting x equals 4. Now, if you recall from graphing systems, our solution was always an ordered pair x and y. What we're just doing right now is figuring out how substitution works. So we're going to solve for x, and in this case, we actually know what y is, but we'll worry about finding both variables in a moment. Right now, we're just getting used to replacing a variable with something that we know it's equal to get a result. And so in this case, we get x equals 4. And so when we move on to example B here, it's the same idea. You'll notice we still have y equals, but y is equal to an expression 3x that involves a variable. So it works just the same. We now know that we can replace the variable y with the expression 3x. These two ideas are interchangeable. And so we're going to use our given equation again. And where we have the variable y, we'll replace that with a 3x. So again, here is our given equation, 4x plus 2y equals 20. Let's replace the y variable with the equivalent expression. And when we do that, we now see that the equation reads 4x plus 2 times 3x equals 20. So we had 2 times y, now it's 2 times 3x. Notice again, the equation now only has one variable, just the variable x, meaning we should be able to solve for that variable, going through some steps that we're familiar with. So let's simplify the equation a little bit. And we have 4x plus 6x equals 20. And combining like terms on the left side, they're on the same side together, so we just combine what we have. So we take 4x plus 6x, and we have 10x equals 20. Dividing by 10 on both sides, we'll get x is equal to 2. And this is the whole idea of substitution, to replace a variable with something that we know it's equal to so that we're able to solve for the other variable. So in this case, we get x is equal to 2. All right, we're going to try one more example of this. We have y equals 4 minus x. So it's kind of like example B, where we have y is equal to an expression involving a variable. It still works the same. We're going to interchange that variable y with the expression 4 minus x. So let's see what that looks like. So again, using our given equation, 4x plus 2y equals 20, we are going to replace that variable y with 4 minus x. And you'll see here that when we do that, it's going to be very beneficial that we're using these parentheses as we substitute, because inside parentheses we have two terms, 4 minus x, and we have this 2 multiplying in the front that we know we need to distribute. So as we simplify this equation, we'll distribute the 2 into our quantity, where we have now 4x at the beginning, and as we distribute the 2, 2 times 4 is 8, and 2 times negative x, or negative 1x, is going to be negative 2x. So we put minus 2x equals 20. We have like terms on the left side here, the 4x minus the 2x, so we'll just combine those. They're on the same side together, so we're not going to cancel anything. Just put 4x minus 2x, and the end result is going to be 2x plus 8 equals 20. Again, 4x minus 2x is just 2x. We cancel the 8. We'll subtract 8 on both sides. We get 2x equals 12, and dividing by 2, we'll end up getting x equals 6. And just like the other two cases, we replace the variable y in the beginning. We get an equation that uses all the same variable now, the variable x, which means that we're finally able to go through solving an equation to solve for that variable. And that's the key idea of substitution. Replace one of the variables so that we can solve. So in our next video, we're going to look at a couple examples where we solve the full system, and we'll see what can happen as we do that.